Hey René, we're here at Techorama recording our podcast live with several speakers.
As you can hear by the sound of it.
We're in a very noisy room in the middle of the conference venue. Um, and it's great to see all the people here, all having a learning mindset, learning new stuff.
Yeah, and it's great that we can record here at Techorama. We have
Yeah,
a
so
wooden booth without a ceiling, but it's great. And
yeah,
we can like receive guests here.
yeah. So at least thanks Techorama for having us and giving us the opportunity to do this. Let's let's create a podcast episode with some of the speakers here. So what I was thinking about is distributed systems are really hard, and when people start building these kind of things, they all always start, yeah, writing all the stuff themselves.
Yeah, not using the platforms, discussing if they should rewrite the microservices discussion.
Yeah, everyone wants microservices now, right? All the tool vendors want you to
Yeah,
use microservices. So, but do you actually have to write everything from scratch? Let's have a guest who knows about this.
yeah. Let's have a guest that actually works at a company that builds these tools and also is an architect of systems like that. And let's have a discussion with him.
Yeah, so welcome, Adam. Yeah, you work for a particular software.
Hi guys, yeah, I do. Thanks for having me. I've been working with particular software now for what is it? 8 years, I think. And we, as you say, we're the makers of a product called NServiceBus, which is a distributed systems framework. It's interesting that you talk about the people writing it themselves, because we see that very often. Actually, we see that very often in the conversations that we have. Because people do try and write things on their own. They use RabbitMQ directly or something like that, which works great. But as soon as you receive that first message from RabbitMQ, you're on your way to writing your own service bus.
Yeah.
Okay, great. I think this is a great topic for the podcast. So let's kick it off.
Okay.
The Lead Podcast, a podcast for leaders in engineering, architecture, and development.
Adam, I've been working with several software development teams building stuff, either greenfield or brownfield, and always the first reflex is building the stuff yourself, right? That's the first thing that comes into the minds of developers, because what's cooler than building your own stuff?
Well, that's the thing. It's fun, right?
Yeah.
Building your own framework is always fun. Because you're
At least in the beginning.
Well, absolutely, yeah. Because you're defining requirements and solving them. Right? You're designing the framework. You're deciding how.
And you're always unique, right? Just like everybody else, your company is so unique. You need to build your own.
That's right. Yeah, like our problems are different to everyone else's.
Of course.
Yeah,
Yes.
we hear that a lot. Yeah.
No, but why would you say building your own service bus in your work at service bus? So that is your bread and butter. But why is that a bad idea? Why would you really recommend against that?
Well, the thing is that it's hard to get right. Okay, it's fun to write, and as you say at the beginning, especially when you're first starting off and you're designing this from scratch, and it's super cool, and you may even open source it and do that kind of thing. But as you start to get into the details, you soon get bogged down into, well, how do we achieve these harder things? Like, how do we achieve reliable retries, for example? Or even basic things like being able to choose different serializers, like do you want JSON, do you want XML, and trying to support all of that. It's difficult to get right. It's very difficult to avoid bugs. I mean, we've spent a lot of time ironing out bugs over the years, and we've managed to iron out most of them. And ultimately it's expensive, right? Because developers, one thing I've noticed, developers tend to sort of underestimate their own time, right? But you can put a kind of like $1 or euro value on that.
Yeah, of course, very easily actually.
Mhm.
Well,
Yeah, I mean, you can spend the next 6 months, so 2-3 people writing your own framework. Think about developer salaries and all the overheads on top of that, like paying for their desks and all the other. That's an expensive way to write a service.
Yeah, and next to that is also time to market, right? If you spend that 6 month months on writing the framework, you're not adding business value at all, and that's why we build software in the end, right?
Exactly. We should always be adding some business value. Exactly. Yeah. And things like documentation. How well do you document it? I've seen a lot of in-house frameworks sort of come and go, and I've not really seen many of them documented really well. Because a lot of it just lives in the heads of the people who wrote it in the first place.
But maybe one step back, because we're already diving into the intricacies of a service bus. But so why would you even use a service bus? Because we directly dive into that, and hoping that everybody knows. But can you explain a little bit about what problems does that solve? Because it's not for nothing.
Yeah, that's a really good question. So I sometimes like to make the analogy of a user using a system as someone walking into a building. So they walk into the building and let's say they place an order. Now, that desk that they go to place that order, they could do one of two things. They could pick up the phone to other departments, so like billing and finance and things, and make the user wait. Like, hang on while I contact these services. One of them might not be available, right? That's the same as a user coming to your website and the website failing to take your order. And that's not what you want to do. Like, as any business person will tell you, the first rule of business is take the money. Right? Take the money, sort the problems out later. That's the recipe for successful business.
Yeah.
The thing with messaging, when you use something like messaging, is you're basically taking that request, you're saying, okay, you want to order something, right? You want to buy something from us. You basically write it down and said, okay, we'll have that, right? And this is why it's good to use messaging. Because when you put a message on a queue, you effectively write it to disk. It's saved. And that's the difference to your users. It's like instant response back. Yeah, we've got your order. Take their money, sort out the problems later. Versus wait, hang on while I do all this stuff in the background, which might fail.
Yeah.
From a user point of view, from a business point of view, that's the difference. It's being able to take the money reliably and know that you can fulfill the order later.
Traditionally, this was viewed as the McDonald's versus Burger King problem, right? McDonald's was cereal, so you entered the line, and if you were in the front of the line, they would help you and you would get your order, and the person in the second in line, they had to wait till ordering before the first person got their order. While Burger King, from the start, they did it asynchronously, so you ordered, you got this ticket number, and then you get to the second queue to actually wait until your order was finished.
That's a good analogy. Yes.
By now, they all changed to the digital boards where you have to order, so they're all asynchronous now. But traditionally, like 5 years ago, it was this difference. McDonald's had just synchronous communication, and Burger King had asynchronous. I always like to use this analogy, but now when they have this digital boards, it doesn't work anymore. But
I've all learned lessons than organized synchronous. But it's a good analogy, and that's what message queuing gives you. Message queuing gives you that asynchronicity as opposed to just waiting in a queue for.
And that's why it's really suitable for cloud, probably, because the cloud is not reliable and sometimes slow and sometimes not available. So messaging is then the thing that you should actually try and implement.
That's actually interesting because the cloud is all about provisioning lots of machines.
Yes.
That's one of the promises of the cloud. You need 1,000 machines, you turn up the slider and you get 1,000 machines. And if 10 of them fall over, I've got another manager to make you doing the work. It's fine. But the thing is, you can only provision at that scale if you're willing to sacrifice some reliability.
Of course.
So, and that's the thing. So if you're not using message queuing and you're doing everything synchronously, then your chances of something bad happening actually go up when you use the cloud. So it's even more important when using the cloud.
So would you say, like, for all the people that are also getting up and say, I'm going to write my own, because that is fun. And the other question that you also hear is, okay, we have this big legacy monolithic system and we are going to move to the cloud. And then, the first impulse is, of course, that we need to rewrite because now it runs on virtual machines, we use batch jobs, all that stuff. So how would you approach that? So you are in a company with a big legacy system, you want to move to the cloud. How do you approach that?
Well, as you mentioned the big rewrite.
Yes.
Now that always sets some alarm bell for me, because the idea then really is that you feature freeze the current system and you say, well, we're going to rewrite it from scratch, and
in a couple of years.
Yeah, I mean, you know,
Maybe,
developers try and sell it as 6 months.
Yeah.
And
Yeah.
I'll be done, and then it never takes 6 months. You know, we're bad at estimating, and it's not necessarily developers' fault because it's difficult to estimate.
It's a complete different episode for the podcast, but yeah.
Exactly. You discover things that you put in that you forgot about, and all these hacks, and you have to reproduce them. And then what I've seen so many times is you get to a certain point and the business says, stop, we've got to stop this rewrite. And you end up running two systems and you're integrating the two together, and that whole thing becomes a new mess.
Yes.
And at some point you want to rewrite that again. So
Uh-huh.
rewrites are always, they always set off an alarm bell for you. I'd rather kind of carve out bits at a time. Like there's a thing called the strangler pattern.
Yeah.
You kind of carve out bits of the old system, replace it with new stuff, and you sort of strangle the original thing out of existence. You know, iterative rather than deep down rewrite.
Yeah. Otherwise, the same. When I hear rewrites, I always see these projects go on for years, and then after a couple of years, they have the first version, and it does the same thing as what they had 2 years ago, right? So that's also why I don't like rewrites. I rather just focus on new functionality and then use that new technology, the new patterns for that new functionality, and slowly gradually move towards that. That
It's
area.
actually a good way to do it. We've talked a lot about messaging and the benefits of that, the better user experience it gives. I often say, well, look for something that's naturally asynchronous. Let's say when you're producing an email to send to a customer to confirm their order, that's naturally asynchronous. You know, you get that email later.
Yeah.
So carve out a little bit of that system. Send a message instead of doing it live. Send a message. Send a message to do that, and do it later offline. You know, do it. Yeah, and then later can mean a minute later, but it's a natural place to introduce some messaging into your system.
And I think actually most processes in the business itself, they are very asynchronously, while it is a trend that developers, they always tend to do things synchronously because it's easier, right? I just request something from you and I immediately get answer. So it's just on the next line of code I can process that answer, right? That's easier.
It's intuitively easier.
On paper it looks easy.
Mm-hmm. I think it's one of those areas where you end up having to trade sort of deliberate complexity for, well, accidental complexity for deliberate complexity, right? Because sometimes people look at a message and say, well, that's complex, right? Because you're sending these messages back and forth to a queue. And this stuff here, which does it asynchronously, synchronously, looks is much simpler, right? But when you look at the code within a message handler, it's often very simple, right? It's very, very simple. So the detail is simple. The overall architecture may look slightly more complex, but that's deliberate complexity. Whereas you end up getting into accidental complexity in the other.
Yeah, and especially if you want to take into account things that can go wrong in the synchronous model, then you need to write all kinds of additional logic to, if this message didn't go, repeat it or whatever, all the stuff that it has to go everywhere in the code. While, as you said, in a messaging architecture, this is intertwined in the architecture on a higher level, so you don't have to do it on all the bits and pieces.
These kinds of things are infrastructure based, and that's an example of the accidental complexity that you end up having to write.
But on the other hand, traditionally we also did things asynchronously with batches. Right? We did the processing stuff like during the day things happened, and then during the night we processed the stuff. So I think that you also have an opinion on that. What I saw in your talk. So can you elaborate a little bit on that? Like, why is batch processing not sufficient?
One of the really common scenarios I see where people are using batch jobs are for reports. Right? And they say, well, we need these reports delivered at 9 a.m. every morning to users' email inbox. So naturally, a batch job is the way to do that. And I actually agree with that, right? I actually agree that if your requirement is a report every day in the morning in your inbox, do it in an overnight batch job. That has other problems like you can become a victim of your own success. If your business is booming, the batch job can take longer and longer and longer and longer. And I've seen batch jobs finishing at lunchtime, which is supposed to be overnight batch jobs. I've seen that in my career. But the thing is, what is often interesting is if you start to look at the detail of what is that report, right? Tell me what that report is. What do you use it for? Just to give an example, maybe they're looking at maybe it's a bank and they're looking at transactions. But they're saying, well, I look at this report. I look for 3 large transactions in this list of 6 countries, and if I see something, I tell my manager, I start a process, right? The thing is, that report is not a requirement. That's a work,
Yeah.
right? That's a workaround that the user's given. But they know that we store the transactions. They know we have a database. They say, okay, I want a report every morning in the inbox. The actual requirement is if I see 3 large transactions and only 6 countries, I want to know about them, right? It's a subtle change in wording, but it means that what we can do instead is use messaging and time-based messaging to do that real time.
Yep.
Right? When a transaction happens, you can store, you can have a look and say, well, is this a large transaction? Is it in one of these forest countries? Add it to your current collection for this week. Later on, 1 week later, you remove it, right? And then you always have this, you always have this information about how many fraudulent transactions possibly for
So it's actually also about challenging your requester on. So what is it that you're actually asking? Do you want a report, which is the means to an end, or do you want?
It's very much about that.
Yeah.
It's really about getting to the actual requirements, not the workarounds, and that is very much. It's very often an organizational problem. It's very difficult for developers to talk to the people who can give those requirements in pure business terms. Without thinking about how the system currently works.
Yeah.
You know, sometimes we have business analysts in businesses, which is sometimes referred to as proxy domain experts. If you're not careful, they can add a layer of indirection that's not desirable because they can't detach themselves from the system. You need to think of it in pure business terms, and then you can do things like you can get that information real time. The report goes away.
Yeah.
Right? As soon as that transaction happens, that might be fraud, you get it in your inbox immediately, and the manager loves that. You know, it used to take us up to a day to the tech. Now you get it real time, and you can translate that to actual money save.
Oh, but it's a typical problem that you see everywhere. We also have customers that ask for, okay, we want to move to the cloud, or we want to move towards system XYZ, and then why? Why are you moving to the cloud? The cloud is not
it's not the purpose. Yeah.
It's not the purpose to move to the cloud. It might be a solution, but
there's a very good technique called 5 whys.
Yes.
Yeah.
Exactly.
And number 5 is just picked a little bit by random, but always goes why, trying to get to the underlying reason, and then all of a sudden an actual requirement might pop out, and then you can think about how you implement that completely differently.
So I love to talk to the actual business people because they can often explain what they really want, and if you have a good conversation with them, focusing on those 5 whys, you can find the requirements quite easily. But what I see happening in so many organizations is that there's so many layers in between the actual business and the person writing the code. They often just pick an item from their backlog and start working on it, doing their own interpretation of what the question was.
I found so often in my career that so many problems in software have their roots in organizational problems.
I think it's the biggest.
You see it grow, right? If you are a small company, you basically do everything yourself. If you're a big company, then you get departments, and then there is this department does this, and the business development department does that, and you do not cross each other's lines. It's like my stapler, my silo. You don't come into my silo. So,
I think it's one of the things that IT leaders can really focus on is just making sure that those developers do get access to those actual requirements, so setting up the structure so that can happen. Make sure the dialogue is happening between the right people so that is allowed to flow to the developers. So they can really get involved and understand the business.
Yeah, I think that is the value of the cross-functional teams, right? It's not so much like putting people together, like also, again, a means to an end, like putting people together. No, it's because then we constantly do not have to ask departments that are protecting their lines.
Yeah, for me, that's also what DevOps in the end is about. You own a piece of the application from front to end, which means the front is the actual business requirement. So you go out to the business or your customers to ask what they need, and in the end be responsible to implement it and run it. and it's not about, oh, you need to make pipelines or those kind of things, right? It's about owning a full application and building the right stuff. If you build stuff that people do not want, that's the biggest waste you can have in your application. If you build features that are not needed.
Yeah, it's often referred to as kind of like vertical slices.
Yeah.
So you take a vertical slice, as you say, from the front to the back, and then you can even organize your teams around that.
Yeah.
Yeah.
Is that then also how you go to work when you want to, well, like not rewrite, but like move a system or change the system? You mentioned the strangle pattern or whatever. So how do you get to work? Do you first form the teams and then the architecture follows, like Conway's law, or do you use domain-driven designs? How do you go to work on that?
In general, I'm wary of too much architecture up front. Okay, so I generally prefer sort of emergent architecture. So I often describe myself as a software simplifier, but I like to do things the simplest way possible first, right? Ideally with no code, right? That's the simplest code that's possible. And then you can let the architecture emerge from that. But I think it's difficult to say that one thing should come first. I think these kind of things, they have to evolve together. So as you start to identify those vertical slices and you start to identify service boundaries and things like that, then you can let your team start to coalesce around that. To be clear, it's a long process usually. It's not an overnight thing. We're talking not even months, but probably years. Okay.
And we're also not talking first time right.
No, you're going to make mistakes along the way, which I try and help out with the talks that I give and things. But it's very much a learning process, and there's obviously some trial and that involves.
So enlighten us. So what are the most common pitfalls like those that I'm trying to teach people in my talk? So what are the things that people should consider when looking at this big system?
Well, we've already talked about the big rewrite.
Yeah.
Okay, that's something which I usually see doesn't work out too well. The more covert, more iterative parts of the system. We need to give I'll just do a recap of some of the stuff we've already. So the getting to the actual requirements, getting past workarounds that are given to you by users, given their knowledge of the system, getting to actual requirements. Definitely trying to write your own things like a service bus instead of using stuff that's already pre-built that's out there in the market. One of the things I talk about a lot is service boundaries. So I'm actually giving a talk here at Techorama about that tomorrow. That's one of the things that if you get that wrong, it kind of leads to chains of other problems. But the key there again is being able to get the requirements. If you can actually get business requirements, it's good because if you can actually talk to a business person, you can use tricks like anti-requirements. Right? So you can ask them really dumb questions like, if a user's name begins with S, does that affect my discount status? Right? And I'll say, of course not. That's ridiculous. Right? We would never do that in this business. That's actually you've struck gold because you're telling there's no relationship between a customer's discount status and their name. So you put them in two different places.
Okay.
Right? But we're very much, the human brain tends to be noun based. We like to hold on to concrete things. So if someone tells us about a customer, we draw a big box on the board called customer, and we create a customer service, which has got the first name and a discount level in it.
Yeah.
But they're completely unrelated. If you go down that route, you end up sharing data between services, and that's the key, and that's where the service boundaries break down.
Yeah.
As soon as you're sharing data between services, you don't really have boundaries anymore. But the key to that again is being able to talk to the business people about that. So that's why I think it's really important for IT leaders to set up those structures where you can really talk to people and ask those kind of dumb questions.
But also have the people in your organization that can actually do it, because they can be brilliant developers, but they are not probably the best people to talk to the business. So either skill them so that they can, because you can learn to ask questions, but also or have different kinds of people.
I think it's really important. Yeah, no, you're right. It's not just about the structure. It's also educating the developers to ask that kind of thing. Because a lot of developers don't necessarily like doing that. They actually like having a business analyst giving them kind of like low-level requirements. But I think where we can really add value as developers is by asking those questions, by really starting to understand the business. And I think that IT leads can look to move their developers in that direction, to actually get them talking, to get the developers talking in the business terms and understanding the business.
Yeah.
It's more of a partnership. Really. It's not just like, I've seen a lot of organizations where you kind of have the kind of the business department and the IT department, which are kind of loosely aligned. I find it much more useful when they're much more closely aligned, and your IT team almost becomes part of the business team. It gets involved in it. I think that's a restructure which can add a lot of value within the organization.
I always find it hard that I fully agree with you on this, but a lot of the engineers I talk to, they don't think this is the most fun work, right? They rather just write code in their behind their laptop or behind their machine and not talking to these scary business people. But I do think it is one of their main priorities that they should have the right skills to do, because otherwise you're not that much of a developer if you can just write code. Yeah,
I mean, everyone's always concerned with job security, right? So that's always a concern. And then you get things like AI and LLMs and Copilot coming up. People go, oh, is this going to replace me? Kind of thing. If you're having those kind of conversations with the business and understanding the business, that's going to be a very difficult thing for AI to replace, if ever.
Yeah.
And you can use things like LLMs and things in Copilot. These are great tools to have in the toolkit, and you can offload kind of a lot of low level work to that. I do that myself.
Yeah.
But I think it's about making developers realize that where they really add value is when they talk to the business.
It's solving business problems.
Now they are writing C#. Maybe in the future they will write just English, and then they get the code. But you still need to punch in the stuff. And I think that is a great mindset shift. Like we really need to level up our game. We need to talk to the business, but also the business also maybe needs to start asking the right questions instead of giving a report. Give me the requirement and give me the data. Give me
what I actually need is
what
this.
I actually need instead of always the solution, like thinking for another one.
Yeah.
And I think that we have a long way to go there.
I think we do, yeah. But as you say, it's about educating both parties in that equation. Yeah.
Cool. So well, I think that we covered a lot of ground. So from moving or the requirements, we had a service bus discussion, monoliths.
Yeah, I even think we started off with build it your own versus buying stuff for messaging. I think this goes for many of the things that developers tend to build, right? First, look at what you can actually buy off the shelf. It doesn't have to be a messaging solution, but all kinds of solutions. Is it really the thing that your company makes money with? Is it really the core of your work, or is it just some context that other companies have specialized on and made solutions for you that you can actually use?
I think that is the biggest takeaway. Like stop thinking about writing your own stuff. Although it's fun, do it in your free time. Build your own.
You can learn from it, right?
You can learn from it, but like if you want to be really successful, spend your time in the business value, as it is with everything. I think.
Yeah, and use commercial or open source tools and platforms to actually.
So, Adam, thank you. Thank you for your time. And I think it's time to wrap up.
Yeah.
Well, thank you very much. Thanks for having me. I really enjoyed it.
Yeah.
It was great.
Enjoy your talk tomorrow
on Techorama.
On Techorama. What is it about tomorrow?
It's finding your service boundary.
Find your service boundary.
Yeah, so it's one of those problems right at the root. Because if you get that right, it's going to lead you down a path of success.
Okay, thank you very much. Enjoy.
Okay, thank you. Bye-bye.
For the listeners, bye-bye.
The Lead Podcast, a podcast for leaders in engineering, architecture, and development.